Thousands of years before clocks, satellites, or digital maps, ancient Egyptians developed reliable ways to measure time, distance, and direction. These measurements were not abstract ideas. They governed agriculture, religion, architecture, and the very survival of the civilization. The flooding of the Nile arrived on a schedule. Temples had to face specific directions. Fields needed to be measured and redistributed every year. Without accurate measurement, Egypt could not function as a unified state. So how did ancient Egyptians measure time and space with such consistency using only the sky, the land, and simple tools? Archaeology offers clear answers. To the ancient Egyptians, time was not merely counted, it was experienced. They believed the universe operated according to math, balance, order, and harmony. Measuring time and space was a way of maintaining that balance. Temples were aligned with celestial events. Festivals occurred on precise dates. Royal authority depended on predicting the seasons. Timekeeping was not a luxury. It was a foundation of power. Long before mechanical clocks, Egyptians looked upward. They carefully observed the movement of stars, especially those near the North Celestial Pole, stars that never set. By tracking these stars, Egyptian astronomer priests established consistent nightly time divisions. Tombs and temples record the use of decans, groups of stars that rose sequentially throughout the night. Each decan marked a specific portion of time. Night was divided into equal segments using these stellar patterns. This system allowed Egyptians to measure time even in complete darkness. Daytime measurement relied on the sun. One of the simplest yet most powerful tools was the shadow clock. A vertical object, often a rod or obelisk, cast a shadow that moved predictably throughout the day. By marking the shadow's position at different times, Egyptians divided the day into hours. Later devices, such as L-shaped shadow clocks, allowed more precise readings. These tools required no gears, no moving parts, only sunlight and observation. Egyptian sundials divided daylight into 12 parts. However, these were seasonal hours, not fixed hours like today. An hour in summer was longer than an hour in winter. This flexible system matched natural rhythms rather than imposing artificial precision. Priests and officials understood this variation and adjusted rituals accordingly. Time, to the Egyptians, adapted to nature, not the other way around. One of Egypt's most remarkable achievements was its 365-day calendar. It consisted of 12 months, 30 days per month, 5 additional festival days. This calendar was synchronized with the hilariacal rising of the star Sirius, which coincided closely with the Nile's annual flood. This connection allowed Egyptians to predict agricultural cycles with impressive accuracy. Although the calendar drifted slightly over centuries, its structure influenced later Greek and Roman systems and eventually the modern calendar. Each year, the Nile erased boundary markers. After the waters receded, land had to be remeasured and reassigned. This task fell to trained surveyors known as rope stretchers. Using knotted ropes of standardized lengths, they recreated field boundaries with precision. These measurements formed the basis of early geometry. In fact, Greek writers later credited Egypt as the birthplace of practical geometry. Egyptians used standardized units to ensure consistency. The most important was the royal cubit, based on the length of the forearm. Cubits were subdivided into palms and fingers. Stone cubit rods found in temples confirm strict standardization. This consistency made large-scale construction possible across decades. Without standardized units, pyramids and temples could not have been built accurately. Egyptian monuments were not randomly placed. They were aligned with cardinal directions, solar events, sacred landscapes. The Great Pyramid's alignment with true north is accurate to within a fraction of a degree. Surveyors likely used star transits, shadow intersections, plumb lines, and leveling instruments. This precision required repeated measurement and verification, not guesswork. The result was architecture that mirrored cosmic order. Measurement knowledge was not secret, it was institutional. Priests, scribes, and engineers were trained over many years. Mathematical texts, such as the Rhind papyrus, show problem-solving methods used for area, volume, and proportion. This knowledge passed through generations, ensuring continuity. Egyptian science was cumulative, not accidental. Modern archaeology confirms astronomical alignments, consistent measurement units. Long-term planning, experimental archaeology has replicated Egyptian techniques using simple tools with success. Nothing discovered requires unknown technology. The achievements are impressive precisely because they are human. Ancient Egyptians did not measure time and space for curiosity alone. They did it to govern, to build, and to survive. Their methods were rooted in observation, patience, and discipline. The pyramids, temples, and calendars remain because they were built on knowledge, not myth. In understanding how Egyptians measured the world, we understand how civilization itself takes shape. This is Secrets of Time, where ancient history still speaks.